Okay, here we have two problems for the same situation over here, where we have a 73 kilogram person in the elevator, which has a downward acceleration of 1.8 meters per second square. So let's consider the elevator. So there is a person in the elevator. Okay, and the entire system goes downward with acceleration of 1.8 meters per second square. Okay, and what we need to find the net force on the person in the elevator first. For that, we will consider this person as a system. What are the forces which act on this person? Well, there is a force of gravity, of course, and there is a normal force. Okay, we do not know the normal force, but what we actually know is the following. We know that mass times of this person times the acceleration in the y direction is given by the net force in the y direction, right? And what we need to find the right hand side of this equation. Okay, which means, but what we know the acceleration ay in the on the left hand side. Okay, and we know the mass. So in principle, we don't need to define the normal force to find the net force right now. All we need to do is just to compute mass times the acceleration in the y direction. Okay, and this will give us the net force in the y direction. So the net force in the y direction, so let me just rewrite this equation, will be mass times the acceleration in the y direction. And it will be 73 kilograms times ay is negative 1.8 meters. So it's times minus 1.8 meters per second square. Okay, or using our calculator, 73 times 1.8, we will obtain negative 131.4 newtons. Okay, or the answer is D. Why is it D? Why there is no negative sign over here is because we need to find the magnitude, so we have to discard the sign. So without the sign, the answer will be D. Okay, so the next part is the following, that as the elevator accelerates down, which of the following statements about the forces on the persons are correct? And there are the statements. Okay, that the normal force is greater than the gravitational force, the normal force is equal to the gravitational force, or the normal force is less than gravitational force. To answer this question, we have to find this gravitational force. So let's consider the normal force, sorry. So let's consider the normal force over here. So what we know is that the mass times acceleration in the y direction is given by the net force. Okay, we found it, it's negative. Or at the same time, it's given by the net force. So this is my y-axis, by the way. So by the normal force, it contributes with a positive sign. Now there is also the contribution from the gravity's force. Its direction is opposite to the y-axis, so it will come with a negative sign, minus m times g. So from this equation, we can actually go ahead and find the normal force. The normal force will be may plus m times g. But we know that the acceleration, so this first term is negative. And this is gravitational force. So we take the gravitational force and we subtract this number, right? So this is a negative number to get the normal force. And this is why the normal force is less than m times g, right? Because this contribution is negative over here. And this is what we get, that the normal force is less than the gravitational force.